Hey everyone, and welcome to another explainer brought to you by Forge College. So if you've been following along with our Applied Solidity development track, you know we're right in the thick of the capstone project. Last time, we nailed down our pre-deployment checklist and got our monitoring strategy all set up. Well, today is the day we actually build the ultimate machine. Let's get right into it.
You know, the absolute chaos of an unregulated, poorly planned token sale, it's kind of like throwing a bunch of loose gears and pistons into a box, shaking it up real hard, and just hoping a perfectly timed Swiss watch pops out. Spoiler alert here, it literally never does. Up until now, we've been carefully milling all those isolated gears, right? Our whitelist checks, our vesting logic, our refund triggers. But today is where the real magic happens. We're shifting away from those loose parts to a unified architecture. We're going to draft the master blueprint to bring the whole shebang together into a high-performance, fully assembled engine.
Okay, let's dive into this master plan. We'll be using this schematic index to assemble our system securely, starting with the master blueprint, then the TokenSaleManager, building the buy flow, deployments, and milestones, and we'll cap it all off with securing the launch.
All right, Section 1, the master blueprint. Time to shift our mindset from isolated mechanisms to a unified design.
So, what's the actual secret to avoiding a massive monolithic failure? It's the TokenSaleManager. Honestly, think of it as a traffic cop. It acts purely as an orchestration layer. It just coordinates the traffic between our whitelist, our vesting, and our refund modules, so they stay safely decoupled. This means if one module needs a fix, the whole system doesn't just crash and burn.
Moving on to Section 2, the TokenSaleManager. Let's look under the hood at the actual skeleton of this coordinator.
The skeleton we're working with here is surprisingly simple. We've got small interfaces, state variables, a constructor, and our core buy function. Now, what's really interesting about this slide is that constructor. By passing our module addresses and our multisig treasury, which is basically our highly secure multi-lock vault, right into the constructor at deployment, we're ensuring accountable ownership right from the start. We are defining exactly where the funds go before a single token is ever sold. And keep in mind, keeping those interfaces small, it's basically an engineering magic trick. By only exposing the exact functions your manager actually needs to know about, you prevent massive composability problems. Plus, it means you can test these components in total isolation using mock contracts, which are essentially fake test versions of your code. It keeps everything clean, readable, and most importantly, it keeps it secure.
Section 3, building the buy flow. Let's look at the actual integration point where the magic happens.
This is the critical three-step heartbeat of our buy function. Step 1, verify the buyer via the whitelist. Step 2, calculate the Ether to token rate and record it internally. And Step 3, actually schedule that vesting. Now notice the exact order here. We absolutely must update our internal state before we start reaching out to any external contracts.
But wait, why do we record the purchase internally before scheduling the tokens? Well, if you're sitting there shouting checks effects interactions pattern at your screen right now, you hit the nail on the head. We do this specifically to stop reentrancy attacks. That's a terrifying exploit where a hacker repeatedly drains funds before the system even registers their first withdrawal. It's a massive blast radius that we absolutely want to avoid. So we limit that risk by updating our internal effects before making any external interactions.
Which brings us to Section 4, deployments and milestones. Because a beautiful blueprint is completely useless without a flawless assembly line, let's map it out. Mapping out specific phases to specific owners is absolutely vital here. As you can see, the engineer owns the tests, the auditor owns security, and the multisig owners control the launch. Putting these strict roles in place prevents this really dangerous thing called integration drift. For example, when you assign a specific KYC operator to handle whitelist updates, there is zero confusion about who's responsible when the pressure is on. And here's the exact rollout timeline we follow. 1. Consolidate your interfaces. 2. Run your automated testing with those mock contracts. 3. Deploy to a staging environment on a testnet. And 4. Execute your production launch with 72-hour monitoring. Now, I really want to highlight that staging phase. It's vital. It's where we validate network transaction fees, our gas costs, especially for massive whitelists, before anything ever hits mainnet. Trust me, you do not want users getting error messages on launch day just because the network fees were calculated wrong.
Finally, Section 5, securing the launch. Let's talk about defensive engineering and what actually happens after we go live.
Whenever you're building in Web3, you always have to ask yourself, what's our blast radius?
This introduces the concept of a risk register, basically your emergency playbook. We have to explicitly link specific on-chain emergencies, like, say, a pause sale, to actionable mitigation steps derived right from our refund module. Having this mapped out in advance, it completely turns panic into procedure.
So the crucial point here is understanding system scalability trade-offs. On-chain composability is amazing. It's completely trustless. But processing heavy data directly on the blockchain is incredibly expensive. On the flip side, off-chain orchestration is vastly superior from massive datasets, like a whitelist of 10,000 users. You have to choose your architecture carefully to protect your users from failing transactions and burning up their gas fees.
All right, let's summarize the core philosophy of our engineering masterclass today with these 3 golden rules. Number 1, design for composition, using small, decoupled interfaces. Number 2, design for verifiability through rigorous, isolated testing. And number 3, design for accountable ownership. This means your multisig and treasury architecture needs to be locked in long before a single drop of funding ever moves. Sticking to these rules ensures that our post-sale processes are actually actionable, not just hypothetical daydreams. Before we wrap up, I want to leave you with this final provocative thought. When the time eventually comes, how will your modular blueprint limit the blast radius of your next smart contract upgrade? Really think about how decoupling your systems today is going to save you massive headaches tomorrow. Next time, we're going to tease out exactly how this works in our upcoming lesson on composing sale components and advanced refund strategies. Thank you so much for hanging out with me for this explainer. Make sure to head over to forge.college to continue mastering this Web3 engineering magic. Catch you in the next one.